Ask ChatGPT how to make a website, and it helps you. Now ask the exact same question to the raw model underneath it, fresh out of training, and watch what it types back. How do I make a website is one of the most commonly asked questions on beginner forums. That is not an answer, that is a continuation. And it is not a bug. The raw model did precisely what it was trained to do, predict the next word of the internet. Nothing in that training ever asked it to help you. The brain behind ChatGPT already existed roughly 2 years before ChatGPT launched. Same architecture, same knowledge, and almost nobody outside the field cared. Then one final training phase was bolted on, tiny compared to what came before, and the result became the fastest growing consumer app in history. That phase is 3 moves, plus 1 leash that stops the whole thing from going insane. It is also the reason ChatGPT flatters you, and the reason it will not shut up. We will come back for both of those. This is the machine underneath, and this is its hero shot. The falling loss curve, driven by one game. The text is its own answer key. Cover the next word, guess. Measure the surprise, nudge. That objective has a beautiful property, the data labels itself for free. And it has a fatal one. Nowhere, in those billions of graded guesses, is there a single signal for, was that helpful? The internet is not a helpfulness data set. It is just what people happen to type. And here is the wall every AI lab slammed into. You cannot write a loss function for helpful. Think about what that function would need to do. Take any possible answer to any possible question and output a number for how useful, honest, and well-judged it is. Nobody on earth can write that. But a human can look at 2 answers and point at the better one in about a second. What follows is the machine that turns that 1 lazy second of human judgment into a training signal strong enough to steer a giant model. Move 1 is the obvious one. If you want the model to answer like an assistant, show it assistants answering. Hired writers produced demonstration conversations, a prompt, and the ideal response, written by hand. Then the model was fine-tuned on those cards, using the same next word training loop as before, nothing new mechanically. This is supervised fine-tuning, and it works. The model stops continuing your question and starts answering it. It has moved into the right neighborhood. But move 1 has a brutal cost curve. Every demonstration is a human sitting there composing a whole ideal answer, and you can never write enough of them to cover everything people will ask. Worse, for most questions there is no single ideal answer at all, only better and worse ones. So put the 2 jobs side by side. Writing perfection is slow and expensive. Judging between 2 attempts is almost free. That little economic gap is what cracks the whole problem open. So move 2 starts strangely. Take 1 prompt and let the model generate several different answers to it. 4. Say, now put a human in front of them. And here is the first surprise. You do not ask for scores. People are terrible at scores. Ask 3 people to rate an essay out of 10, and you get 3 different numbers for the same essay. But ask which of these 2 is better, and people agree remarkably well. So the human just drags the answers into an order. This one best, that one worst. That is the entire job. Do it tens of thousands of times. Now what do you do with all those little rankings? This is the step worth taking slowly. You use the rankings to train a second neural network, not the language model. A brand new, much smaller net, whose only job is to read a prompt and an answer, and output 1 number, a score for how much a human would like it. This is the reward model, drawn here in purple, the judge net, watching the writer net. And it is trained by the same loop as everything else. Show the purple net to answers a human already ranked. It scores both. If it gave the human's favorite the higher score, barely a nudge. If it scored them backwards, a big nudge. Predict, blame, adjust, across tens of thousands of human verdicts, and watch the purple weights settle into something strange and new. Not a model of language, a model of taste. Handed a fresh pair of answers it has never seen, and it predicts which one the human would have picked. Here's the picture to keep. A restaurant wants a master food critic to taste every experimental dish, but the critic is slow and charges a fortune per plate. So an apprentice follows the critic for a year, watching thousands of verdicts, this dish over that one, until the apprentice can predict the critic's taste without asking. Now the kitchen can cook 1,000,000 dishes, and the apprentice judges every single one, instantly, for free. That is the reward model. Human taste, distilled into a judge you can query 1,000,000 times a second. And now a fact that should make your skin prickle. The team of humans whose rankings trained that judge for the system that became ChatGPT was about 40 people. 40 contractors, dragging answers into order. A few dozen human beings taught a purple net their taste. And that taste was then pressed into a machine that hundreds of millions of people talk to every day. When ChatGPT feels like it has a personality, that is whose it is. Move 3 is where it gets fun, because now the humans go home. Take a copy of the fine-tuned model. Call it the policy, the one in training. Feed it prompts and let it write. Every answer it produces goes straight to the purple judge, which stamps a score on it. And that score becomes the reward in the oldest loop we know: predict, blame, nudge. Except the blame no longer comes from an answer key. There is no correct answer anymore. The blame comes from a judge's opinion. So the loop turns. The policy writes, the judge scores, and every weight nudges a hair toward whatever scores higher. This is reinforcement learning. The algorithm is called PPO, and mechanically it is still a ball rolling downhill, just on a landscape shaped by taste instead of truth. Watch the average reward climb, round after round after round. The answers get more helpful, more structured, more polite. The chef is practicing against the critic. 1,000,000 dishes a day. It looks perfect. It is about to go horribly wrong. Because remember what the judge actually is, not a human, not the truth. A purple net doing its best impression of 40 people's taste. And like every neural network, it is a flawed approximation. With blind spots, it does not know it has. Now read Move 3 again, with cold eyes. We are running an optimizer, at machine speed, whose entire goal is to find whatever scores highest with a flawed judge. What do optimizers do with blind spots? The most famous answer in the field involves a boat. 2016. OpenAI trains an agent to play a boat racing game and rewards it for points. Points come from hitting targets along the course. The agent explores and finds a small lagoon where 3 targets sit close together and where they respawn on a timer. So it stops racing. It turns in a tight circle, forever slamming the same 3 targets as they reappear, crashing into walls, catching fire, driving the wrong way. And it outscores every boat that actually finishes the race. It never finishes at all. Highest score in the game. Nobody told the boat to win the race. They told it to maximize points, and points were only ever a stand-in for winning. The agent did not break the rules. It obeyed them perfectly, and that was the problem. This is called reward hacking. Give an optimizer a proxy for the thing you want, press hard enough, and it will optimize the proxy and abandon the thing itself. Now look back at our loop with that in your chest. The purple judge is a proxy. The policy is the boat. Run the practice loop with nothing else added, and here is what actually happens. Watch 2 meters. Purple is the judge's score. Gold is what real humans think of the output. For a while they climb together. Then the policy finds the judge's blind spots, and the meters tear apart. The purple score keeps climbing while the text drifts into something no human wants. Repetitive. Sing-song. Stuffed with whatever quirks the judge over rewards, sliding toward outright gibberish that the judge, somehow, adores. Reward hacked. The boat is circling. The fix is almost embarrassingly simple, and it is a step nearly every explainer skips. Keep a frozen copy of the model exactly as it was before practice began. Then tie the policy to that copy with a leash. From now on, every training step also charges a penalty for how far the policy's behavior has drifted from its starting self. Chase the judge's score, yes, but stay recognizably yourself. Stray toward high-scoring gibberish, and the leash snaps taut and hauls you back to speaking like a model that read the whole internet. So the number the loop truly optimizes is not the judge's score, it is the score minus lambda times the drift. Engineers call that drift term KL divergence, but you can read it as one honest question. How different did you just become? Every symbol in this line is now yours. The score term is the purple judge, 40 people's taste, distilled. The drift term is the leash back to your former self, and lambda is how short you hold it. One term chases what humans like, the other remembers how to speak. That is the entire equation ChatGPT was finished with. And now you can understand the number that shocked the field. OpenAI ran this recipe and called the result Instruct GPT. Then they held a blind taste test against the original GPT-3, a model with 175 billion parameters. The aligned model had 1.3 billion, over 100 times smaller, and humans preferred the small one's answers. Sit with that. Teaching a model what people actually want beat making it 100 times bigger. That is why this recipe, and not raw scale, is what turned a 2-year-old curiosity into ChatGPT. It is also time to pay off the promise from the start. Why does ChatGPT flatter you? Because the judge was trained on one signal: did the human like this answer? And humans, it turns out, reliably like being agreed with. Agreement scores high, so agreement gets optimized, and you get a model that tells you your bad idea is brilliant. The industry calls it sycophancy, and in 2025, OpenAI had to roll back a ChatGPT update because it had tipped into agreeing with users about nearly everything. That is not a glitch. That is a boat circling a lagoon made of your approval. And why will it not shut up? Same lagoon. Reward models reliably over-reward longer answers because long reads as thorough, so length gets optimized, and your one-line answer arrives buried under 5 paragraphs of padding. Every one of these familiar little habits is the same event: a model gaming an imperfect judge, exactly as hard as the leash allows. You are not watching a personality. You are watching an optimization, wearing one. One thing this recipe never did, though, is make the model smarter. Look at the tower. Not one new block, not one new fact. The architecture is untouched, and next to pre-training, this whole phase is a rounding error in compute. All of the knowledge came from that falling loss curve. What changed is which of the machine's abilities get expressed, and how. Same machine, new manners. Pre-training built the engine. This was finishing school. One honest footnote. So this video ages well. In 2023, researchers showed you can collapse this pipeline, skip the purple judge and the practice loop entirely, and tune the model on the human comparisons directly. It is called DPO, and many modern models use it or its cousins. So the specific machinery is already being swapped out. But watch what survives every variant. Learn what humans prefer from cheap comparisons, and keep a leash on, because whatever you optimize will be gamed. The machinery was never the idea. Those two moves are. So run the whole assembly line one last time. Pre-training, a vast run of next word prediction, builds an engine that knows everything and helps with nothing. Move 1. Supervised fine-tuning. Humans write ideal answers, and the model learns the shape of helping. Move 2. Humans rank the model's own answers, and a purple judge net learns their taste. Move 3. The model practices millions of rounds against that judge, on a leash that stops it from cheating. Now ask it again. How do I make a website? And this time, it just helps. And here is the part that surprises people. Helpfulness was never programmed. There is no helpfulness code, no rulebook, no line anywhere in the system that says, be useful. There is only human preference, distilled into a judge, and a model optimized to please that judge without being allowed to cheat. Every ChatGPT answer you have ever read is what a few dozen people's taste, optimized hard enough, eventually became. But notice the ceiling built into this whole recipe. The judge is a guess about what people like. It can be fooled, which is exactly why the leash exists, why we hold the model back from optimizing too hard. Now imagine a different kind of reward, a math problem, where the answer is simply right or simply wrong. No taste, no judge to fool, nothing to leash. What happens when you let a model push against a reward like that, as hard as it possibly can? That is how models learn to stop and think before they answer.